Hello, this is Jennifer Martinez, and in this video we're going to talk about functions and equations. And it says here that recall that solving an equation means finding the values of the variable that make it true. So for example, when we did it in section B.1, we solved some linear equations. It says, without writing down anything, can you figure out what the value of x make each of the following equation true? So notice we do have an equation here since this is an equal sign. Without writing anything down, we know that 6 plus what is 10? 4. But we also have learned that we can subtract 6 from both sides and get that answer. But we have not learned how to do that yet for part B. But what would make that true? 7 divided by what is 1? The answer is 7. You can, if you want to know how to do this algebraically, you could multiply both sides by x. So you would have 7 equals x. The x's would cancel. The 7 would be on the other side. Let's just rewrite that. 7 on this side equals x. And that would be your answer. 6 plus what, even squared, is 6. The answer is 0. And again, you can see that we have not learned this as well, but notice how you can estimate that by subtracting 6 on both sides, and we have looked at something like this. What squared is 0? Well, the answer is 0. The only thing that would, you multiply something by itself to be 0, would be 0. You can also solve any equation using a graph. So even when we don't know how to solve something, we haven't solved anything with x cubes, we could solve the equation, which is what they're going to do in part B. But for part A, let's just review what we did in the last section. What is f of negative 1? If you remember, negative 1 would mean the input. And let's call that x. Let's call this f of x. And this would mean the x right here because of that. So it would be when the x is negative 1. So f of negative 1, we know is, you look at where the x is negative 1, so it's this point right here, and you look at the output, the f of x, and the answer is 6. Similarly, f of 1, oh, that is just 0. Because f of 1 is just right on that line there. Again, this is the x, and we're looking for the whole output. So I'm going to use that idea to solve this equation. So if you remember, f of x was this whole thing. This whole thing is f of x. So I'm going to look for where f of x is 3. So now the 3 is at the output, the f of x. There it is right there. And you can see that the x is 0. And it does make sense if you do a check. 0 plus 0 plus 3 does equal 3. If you don't see that, I did that here. I rewrote the equation. And then I plugged in zeros and realized that these two are just zeros. Another example of solving an equation is using a table, which I usually don't do much, to be honest with you. I think this is a tougher method to solve than using a graph, especially since we have our graphing calculators. I'll show you that in a minute. But here it is. Since we have not done this yet, I'm not going to use this as an exercise, but as an example. But if you think you know how to do it, you can go ahead and pause. So what I'm going to do is I'm going to plug in what they're asking here. It says fill in the table. So I'm going to plug in a negative 2 for each expression. So in the first one is going to be 2 negative 2 squared plus 3, which by the way is 4. You have to do the exponents first. Negative 2 times negative 2 is positive 4 times 2 is 8 plus 3 is 11. is the answer there. On this one, it's going to be 4, negative 2 plus 1, so that would be negative 8 multiply first plus 1 is negative 7. That would be the answer of the second one. If you want to go ahead and try the rest and then come back to see if you got those correct answers, that would be great. Okay, let's see if you got the answers I got. I got 5 and negative 3. 3 and 1. 5 and 5. 11 and 9. So we could just do a couple more. Let's just do this one, for instance. This one would be 2, negative 1 squared plus 3. Again, that's 2. Negative. You have to do exponents first, and negative 1 times negative 1 is 1. And then that's where you get 2 plus 3, which is the 5. Plugging in, oops, I meant the second one. Plugging in the second one, the negative 1. That would be plugging in negative 1 here. 4 times negative 1 plus 1. You get negative 4 plus 1, which is indeed negative 3. And then you can do the same similar procedure to all of those. So I'm going to do part B. Use your results in the table to solve this equation. So we want to know where this is equal to this. And you notice that these values are always different. Oh, let's erase this, except for 1. 1, if I plug in 1 on this side, it makes it a 5. If I plug in 1 on this side, it makes it a 5. So you can see, even though we don't know how to solve this yet, that x equals 1 would make that a true solution. And they say you can use it to use results in the table to solve 2x squared plus 3 equals 5. That is just going to use the top one. So I'm going to use, oh, there's more than one answer, isn't there? There is, because when x equals 1, it's 5, because we saw that there. But you can see here, there's another one here, and we're not going to use that second column, just the first one, because again, this is that first column. And you can see x is also equal to negative 1. If I plug in negative 1 there, it is also 5. It didn't work for part B because we would plug in negative 1 on the bottom one. It's not also 5. So let's go to the next page. Now you can try this. Do the same thing we did in the example. Exercise 2 says solve each equation without any manipulation, like in example 1. So see if you can figure out the solutions. I realize we have not gone over these yet, but see if you can figure out these solutions before we continue. Are you ready? Yes, the answer here is 7. Why? Because looking at the top here, if I plug in 7 minus 7, it's 0, and 0 divided by anything is 0. Here, what would that be? I was thinking it would be 0, but 0 would work here, but then it would be negative 9 here. So I'm going to go for the 0 again. Z equals 9 would work, because 9 minus 9 is 0, 9 minus 9 is 0. Oh, and exponents. So these are all, well, some of these, I think we could actually do this one. But this one right here, we've never learned how to do. We're going to learn how to do this at the end of class. The very last chapter. This means 2 raised to the t minus 1 is 4. Well, we know 2 squared is 4, so we want this to be a 2. So if t equals 3, then I'd have 3 minus 1 is 2, and 2 squared is 4. You could solve this one by our methods. You would just have to get rid of the fraction first, and because there's a parentheses there, it's like distributive law. And you can see that x minus 7, you would add both 7 to both sides, and you would get the answer. On this one, we've done this one before. 9 minus z. What I would do is, here, let me do it over here so it doesn't run into our work. I would subtract z from both sides, subtract 9 from both sides, and then divide both sides by -2. And you can see you end up with that answer. There's no way to do part C until we get to the end of the text. Exercise 3. If a business software company sells X packages, then its profit per package, P, in dollars is given by this formula. So X is the number of packages it sells, and P is the profit in dollars. So how much profit per package do they make if they sell 500 software packages? If you know what to do, go ahead and try it. Pause, and then come back. So I'm just going to rewrite X, what it is the number of software packages, P, the profit in dollars to help me out. This one is they want to sell 500, so that would be the X. So I'm just going to plug in X into this formula, or plug in 500. Use order of operation and divide first, which is 200. So the answer is 9,800, and that's in dollars. Okay, let's do it the other way around. What if we want to write an equation to solve how many packages, want to find the X going backwards that they sell to make the profit 8,000. So now this is the profit, isn't it? So I'm going to do the same thing I did over here in the equation, but now I'm going to put the 8,000 in for the profit. And how do I solve this one? This is not linear. We have not learned how to solve this yet. So we could make a table. But let's go ahead and use the graph idea. So what we're going to do is on our calculator, or Desmos if you want, but I'm going to do the calculator. We're going to graph this and graph this. And then we're going to see what this looks like. So we're going to put this in y1 and put this in y2. Don't forget you need to start with y equals. Step 2, we do have large numbers here. So luckily they gave us the window. We'll look about how to do that on our own later. And then step 3, if you remember, we're going to hit graph. So those are the steps. So let's do it together. Okay, y equals, there it is. Type in these two functions. When you type in the first one, you can't see the whole thing there. But don't worry, when you go to the right there, it is there. So let's go ahead and do that. So if I hit the right arrow button, there's arrows on the upper right side of your calculator. And if you hit that, there's the 100,000, the division sign. And don't forget the X is that XT theta right on next to the alpha button, the green alpha button. To get to the second line, I'm going to press enter at the bottom right and then type in my next one, 8,000. Remember, that's what the Y2 was on our directions over here. Then we're going to go to window and type in those values. So I just changed my X min, my X max, left the scale alone. The Y min and the Y max is what they're asking for there. And then step 3, I'm going to go to graph. And we get 1 and 2. So the intersection where they're both 8,000 is right there, that point. There's an X marks the spot. And you can see here, it lists X is 50, so the answer is 50. So if you plug in 50 in for X, you would get 8,000. That's it.